Good morning, good afternoon, everybody. My name's Rob Jenkinson, and I work in the central EHS and sustainability team in SKF. And I'm going to start off by talking a bit about how we in SKF are working towards net zero. And then I'll hand over to my colleague Per Olaf, who is going to talk about how we can help you, our customers, to achieve net zero, to reduce your CO2 emissions through different application engineering solutions. So just to start off with, I think it's worth giving a little bit of context. The sustainability challenges overall and climate change in particular are really being, to use the technical term, internalized quite rapidly now. So we see stakeholder responses from governments, regulations, incentives that promote energy efficiency, promote clean energy technology, and penalties that start to really penalize carbon emitting activities in industries. We see changes in consumer behavior. We see the investor community really stepping up and focusing on these things. And what that means for us as a business, and of course for our customers, is that climate change, in fact sustainability overall, but climate change in particular, which is the focus of this session, is really coming into some serious and significant business opportunities and risks, and we just list a few of those underneath the bullet point there. I think you can say that there's this great acceleration in all of this focus and all of the money and drivers really around these issues. So it's a really great time to be working in sustainability and to be able to start to really influence this. In SKF, we drive sustainability and action on climate change in two main ways. Firstly, the way we make business, which is really our operations, how we run our facilities, how we work with our supply chain, our logistics, and all of those things. And that's what I'm going to talk about briefly this morning. And then secondly, the business we make, so what we do with you, with our customers, to help you become more sustainable, use less energy, lower CO2, and so on. So first part of this presentation is looking at the left part of this picture, and the second part is very much on the right-hand part of this picture. So looking at climate and looking at the sort of CO2 impact along the full sort of value chain or life cycle of SKF, this is a visualization of that. And the size of the different blue boxes indicates the sort of magnitude of the CO2 impact, greenhouse gas impact occurring at those different stages. And what you see is the use by customers where the products are running in your applications is by far the most significant. In fact, this picture sort of shrinks it down. It's actually much bigger than that. And that's why it's so important that that we have the application engineering focus and really helping our customers to reduce that impact. But I'm going to talk then about the so-called cradle to gate, or the raw material to finished product delivered to the customer, and what we're doing to understand and reduce the greenhouse gas emissions there. So you may be aware that SKF quite recently, just a couple of weeks ago, announced our ambition to be net zero by 2050 for that full impact. So everything from the raw material, the steel that we buy, and everything else that we buy, to our own manufacturing, to the transportation, and all the other aspects will be zero by 2050. And I'll talk a bit more about that in a moment. But actually, prior to that, last year we announced our goal to be net zero by 2030 for our own operations. This is really, the factories that we run and the operations that we run directly. So let's zoom in a little bit on that and see what we're doing there. So our net zero goal for 2030 is basically we have two strategic levers to achieve that, and we're pretty confident that we will achieve it. The first one is the sort of horizontal line there, which is the improving the energy efficiency within our operations, but also material efficiency and general quality, basically eliminating all forms of waste in our own operations. And the second one then is increasing the share eventually to 100% of renewable energy, mainly electricity, that we use. And with a combination of those two things, we are really confident that we'll be able to get to zero by 2030. So where are we so far? We've achieved as a group more than a 40% reduction in our absolute CO2 emissions since 2006, and that's in a period when the business has grown by something like 60%. Currently, about 40% of the electricity that SKF buys is renewable, green, and we have an energy efficiency improvement target, which is 5% per year on year. Last year we didn't do so well. I think, you know, it's pretty obvious why, COVID implications and so on. But that's our sincere ambition, and we believe that's achievable in the medium term. And then if you just look at the actual performance, so this is total CO2 emissions, scope 1 and 2 since 2015, and you can see that we've been very much reducing year on year. And as I said, we're confident that we'll be able to get to zero by 2030. One of the things that gives us that confidence is the fact that we've already done it at a number of operations. SKF now has 3 manufacturing sites around the world which are carbon neutral without the need of any offsets. So this is an example from Spain, Tudela in Spain, making bearings for the automotive industry, and basically with a combination of investment in renewable energy, photovoltaic, sourcing of 100% green electricity, and then an innovative use of heat pumps, geothermal heating and cooling system. This is a fully electrified facility. There's no fossil gas or any fossil fuels used in that facility, and it is already carbon neutral without the need of any offsets. 2 other factories that we have, one is our flagship factory in Gothenburg in Sweden, and the other is a facility in Austria, in Steyr. And there are many more in the pipe. So, you know, we can see that this is achievable, doable, and so therefore confident that we'll be able to get that 2030 goal. Of course, the bigger scope that we talk about, that everything from the raw material to the finished product is a bigger challenge. But again, we are committed to getting to zero by net zero by 2050. And I would encourage you to have a look at a white paper that we published a few weeks ago, which really goes into quite some detail about all the different elements of this, what the different impacts are, and what we intend to do and already are doing to measure and actually reduce those down to zero. So I think the link is going to be put in the chat of the meeting here. So please do take a look at that, and hopefully you get a more detailed understanding of exactly how we're going to deliver this. But essentially, we have interim goals every 5 years going out to 2050, and all of this work is SKF has signed up to the Science Based Targets Initiative, which is basically you know, committing and making sure that our targets are verified to be in line with the Paris Agreement 1.5 degree scenario. So all of this work is aligned with that. The last thing I wanted to say was, you know, we're doing a lot of this work in our own operations directly with our suppliers, but we also see that for some of these things to happen, we need changes in regulation, we need changes in the overall sort of industrial ecosystem, if you like. And as a single company, there's only so much you can do to influence that. So we are working with other companies to advocate for policies, industry approaches and so on that will accelerate this whole decarbonisation process. And we do that through multi-stakeholder initiatives, and these are some of the main ones that we're part of. RE100, which is companies committed to sourcing 100% renewable electricity. Steel Zero, which is a relatively new one, that's companies committed to sourcing 100% carbon-free, in the sense of embodied carbon-free steel by 2050. Great organisation. I encourage you to look at that. Science-based targets I've already mentioned, and Responsible Steel, which is the global standard for responsible steel production. So with that said, that sort of gives you somewhat of an indication as to what we're doing internally. And now I hand over to Per-Olof, who's going to talk about what we can do for our customers.
Thank you, Rob. My name is Per-Olof Johansson. I'm working as a senior application expert within SKF, and have working as application engineer for many years. And I will talk a little bit about the CO2 emissions from bearing arrangements. And by doing that, I will start putting a question to you. Do you know that 20% of the total energy production worldwide is used to overcome friction? And the second question, do you know that 3% is used to remanufacture worn parts and spare equipment? This information is taken from the source that you can see on the bottom here. And having that in mind, it's good that we have rolling bearings, which are designed to provide bearing function with low friction and with high reliability. So that's good, and we are using that, well, many of you, I know that. But still, bearing arrangements can be designed in different ways, so which can influence the CO2 emission. So we will look into that a little bit. And this illustration is intended to show you the life cycle of an application that you have. You can see from the prototyping, piloting, the machine goes in production, in the service, and then it's taken out of service. And we from SKF can support in different ways and at different time in this during this life cycle. For instance, when we are selecting products, there can be a decision needs to be taken. Shall I go for a sealed bearing or an open bearing? We will come back to that a little bit later, what is meant with that. We can also help to downsize the equipment and by that reduce weight and material. And it's not only by reducing the undersides of the bearing, because if we it will also influence the surrounding equipment. So that is something that we can do in this early phase, selection of products that goes into. Another example where we can support is when you're assembling the machines. Different assembly methods exist, of course, but the correct mounting is very important to extend or to secure that we have the bearing life that we intend the machine to have. If we do something, if we do a mistake here, it might have consequences that the machine will suffer from it later on. And another example here, when the machine is in the service life strategy. For instance, in some application, it can be beneficial to have an automatic lubrication system compared to a manual lubrication system. By that, we can improve or reduce the amount of grease. And also not missing, it can, by using automatic, we can also increase the health and safety. So reducing risk for injuries during operation. And just another example is here when the machine is coming to its end, it might be worn, and we have ways to support you reducing or to reduce material, and by that also save energies. So there are different examples of what we can do around the life cycle of an application. And we have made a way to estimate the emissions for different and compare different application, different scenarios for a specific application. And when we do those calculations, there are some things that we are including. I give some example of what we include and some examples what we not include, of course. So bearing manufacturing, meaning that it takes from the initial installation, for instance, you have having the bearings, and we are considering the weight of those bearings. We are not including as I said earlier, if we have a downsizing, what achievement or benefit that can give, that we don't have. But we look on the bearings, so to say. We are estimating the possible bearing replacement over the time of interest. Over the time of interest, I mean, if we have an application and you look on the time, what is emission over 1 year, there will not be any bearing failures. But maybe if we have the time horizon is 10 years, then if the bearings are exposed to poor lubrication or water ingress or whatever, can be in the reality, there will probably be some bearing replacement. So that we are considering. So we're doing estimates how many bearings are replaced during the time of interest. We are including power loss from the bearings. I mean, the rolling friction inside the bearing makes power loss, and also the friction from the integral seals. When we have a seal bearing, it will cause some friction if the seal is contacting. So that it will cause some friction. So that we are including. We have also possibility in the calculation setup that we have possibility to include power loss from external sealing arrangements. But of course, that is the external seals is something that the customer design and can make in different ways. But if we know that, then we can include that also in our estimates. Grease consumption, we have different solutions will require different amount of grease. As I said earlier, if there are ingress or contamination, you probably have to purge grease to a higher extent if you compare to if you have a seal bearing arrangement. So that is example of what we are including. And just some examples of what we are excluding. For instance, if you use an external lubrication system, that probably will cause some emission from that as well. That is not included. If you need to do a replacement of the bearing, we are not including the emissions from that replacement work when we are replacing bearings and other components. So we're only, so to say, looking on the direct emission from the bearing itself, not additional work. And other example is from manufacturing of seals. No, we're not including that. Manufacturing lubrication system and or similar things. So of course you can see there are many things that we're not including, but a big part and where we have a big impact still is included in our estimates and how we make it. I will share some examples, and we have 3 different examples. The first one is taken from the mining industry. And what we're going to look into is emission from a high pressure grinding rod. And the comparison, looking into the future and making the comparison, we will having one solution is with an open bearing and one with a seal bearing. So that is the 2 bearing variants solution for this application that we will compare. I mean, you can see this bearing is open. Depending on the external sealing arrangement and how you do it, there is a high risk that contaminations can enter into the bearing and then destroy the surfaces, and you maybe need to replace the bearings. But in this seal bearing, it's higher protection, of course. So we look into this. In this case, we should bear in mind it's the operation itself, where the machine is very low speed, very high load, and therefore we have very large bearings. So the bearing weight here is 3.3 ton. So it's not probably not shown on the picture, but imagine it's a huge bearing, outer diameter like this, and 3.3 ton, and they are relubricated. So both the open bearing and the seal bearing is relubricated, but a much lower amount of relubrication amount for the seal bearing. Time of interest, we look on 10 years period of interest. So from installation and operating this, and in the figures you can see, we are assuming 16 bearings into this application. And when we do this estimate and comparing, so then we can see on the left side here, we have the manufacturing of the bearing. So we are considering the initial installation of the 16 bearing, and over the 10 year, we are expecting bearing to be replaced over that. So we are considering that. And then you can see the emission from this manufacturing for the open bearing and compare it to the sealed bearing. And there is a considerable lowering amount of emission. When we are operating, the frictional losses from the bearing, then you can see that is a big part, and this one with the seal is somewhat higher, and that is coming from the friction, additional friction from the seal that we have on the bearing. And here you can see the grease consumption, how it goes down. So this is for the open bearing and this is for the sealed bearing. So you can see and compare these figures, and if we take it in percentage, it's 16% reduction for the sealed, going for this solution with the sealed bearing. We should not forget that if we have this type of sealed bearings, the chance to make a remanufacturing is increasing. So that is one example. Looking into the second example, now we are going into the steel industry. And it's a continuous caster machine. And also here we are comparing spherical roller bearings, and with open and compared to sealed bearings. So here we have the open bearing and here we have the sealed bearing. In this comparison, in this application, it's also low speed and also very high load in relation to the size of the bearing. They are relubricated, both the open and the sealed, and this time the bearings are small, so to say, compared to the previous one, 8 kilo. In this, for the figures here, we are looking at 5 years period of interest, and for each application, so to say, we have 100 bearings, 100 bearing positions. And again, we're looking into the manufacturing of the bearing. So this is the emission from the open bearing, and this is from the sealed bearing. So you can see we are expecting to have fewer replacement of this bearing. There are replacements also for that over the period 5-year time of interest. It will be a replacement, but it's considerably lower, as you can see. Again, the frictional losses is somewhat higher for the sealed bearing. And the grease consumption, there is a significant reduction of the grease consumption. You can see it here. So for the sealed bearing, it consumes much less grease. And if we sum it up, it's a reduction of 66% of the CO2 emissions for the two solutions, which is and also here, by using the sealed bearing, we can increase the remanufacturing potential and then remanufacture and reuse the material that we have inside the bearing. We have not considered that, but it is we should bear in mind for this. The third application is an electrical motor, and it's of an industrial electrical motor type. And I'm talking about deep groove ball bearing. So it's a typical or a very common bearing type in these applications. And we will compare what we call standard bearing versus a hybrid bearing. And first to say a standard bearing, what we're referring to then is the bearings made of steel, where the rings and the rolling elements are made of steel. But with a hybrid, then we have replaced the rolling element, the steel rolling element, and we've replaced it with ceramic rolling elements. And that gives a lot of benefit for the bearing, and then which can then be utilized in the application. It will give lower friction, it will prolong much longer grease life, and there are other benefits as well with this hybrid bearing solution. Again, looking into it, this application is very different from the other ones. We are really having high speed of the motor, low load compared to what we saw earlier in the other cases. We are comparing that we are relubricating the bearings, and now the bearing weight is 4 kilo, so it's smaller bearings again. The figures are based on 10 years period of interest, and we are looking on 200 bearings, so that is just to see the emission value, so to say. And from the manufacturing, of course, now we have 200 bearings, but lower weight, so the manufacturing impact is lower. But it's a big difference, and that is also that we have fewer replacement of these hybrid bearings. So percentage-wise, it's a big difference, even though actual level is small. From the power loss, the frictional loss during the use phase, there we can see the friction or the power loss and the emissions from the standard bearing, and there is a reduction for the hybrid bearing. And then the grease consumption, also again, low figures, yes, but the difference is significant. Up 12% reduction of CO2 emissions. And a benefit that we can have with a hybrid bearing is that they are electrical insulating, so you will avoid unplanned or unexpected damages or failures coming from passage of electrical current in those bearings and these applications. So this was some examples where we can use our knowledge and put it together and put the outcome in terms of the view of CO2 emissions. And we gave it as some examples. And we think, or how we see upon it is we can work together to create even more sustainable solutions. And we from SKF, we know about bearing arrangement, bearing types, how to install them, how to handle it. But you know about your application and the process where the machines are used. And then together we can help and we can work out solutions. So we can reduce the CO2 emissions. And actually, that was the last slide that I had to make this presentation. And just to mention, this is the first session around sustainability on this topic where we look into application. We are planning to have more sessions where we focus on specific industries and what can be done there. So please stay tuned.